I want to thank everyone for joining us today for this webinar. To give you a heads up, this is a little bit different scenario that we're trying out. We spent some time with the Renishaw folks in Illinois to help produce this video. So it's actually pre-recorded. It's not live, me doing anything and then jumping over to Renishaw, so you'll see this video, but it's going to highlight a lot of really neat things that we are doing with on-machine probing, and of course with Renishaw Productivity Plus for NX Cam, or like we like to call it, NX RSP Plus. The way this webinar is going to work here is we're going to run this video. It's like 37 minutes long or so, so it's not too overbearing. There's a lot of good stuff about not only Janus Engineering America as our company and what we can do, but of course, all machine probing. That's why you guys all showed up for this webinar today. So it's kind of a little bit of a show, tell, show scenario where we're actually going to show the process with inside of NX Cam and how we drive these probing solutions. And then we're going to go to another video clip and have Stephen Kerr from Renishaw USA talk about us at the machines. We're going to see some live on-machine probing or pre-recorded on-machine probing. Once again, I want to thank you guys for joining. So at the end of this, we're going to open up the Q&A for this webinar. I think we're going to do a hand raising or type in a question, and we'll unmute you, and therefore you can ask the question live, and then Stephen Kerr or myself, Stephen Kerr from Renishaw, or myself will answer questions according to your requirements. I want to thank you guys for joining. We're really, really excited about this product and what it can do for you as far as on-machine probing, increasing your product quality and, creating some automation in your manufacturing process. So without any more, let's get started with this.
Hello everyone, and welcome back to another installment of The Automator. My name is Tim Falcone. I'm CEO of Janus Engineering Americas, and today we are in West Dundee, Illinois with our good friends Renishaw USA to show off Productivity Plus for NX Cam. Today's webinar is going to highlight how we can increase our throughput by automating our probing solutions as well as inspecting parts and decreasing our scrap at the machine. Come back with me and let me show you how it's done. Oh, hey, look who we have here, Mr. Stephen Kerr. Stephen's going to show us today how Productivity Plus is going to change your manufacturing automation for the better, decrease scrap, and of course, inspect the machine. Say hi, Steve.
Hi, guys.
Let's get going with this project.
In today's webinar, we're going to talk about Renishaw Productivity Plus for NX Cam, or as we like to call it, NX RSP Plus. This presentation is going to focus on a day in the life of the operator and the machine programmer. We're going to show you how to maximize your throughput, decrease scrap, prevent crashes, and of course, make better quality parts and more money on every machine tool you own. Before we dive a little deeper into the webinar, I want to talk a little bit about Janus Engineering. Of course, Janus Engineering offers premier support services for Siemens PLM products, including NX Cam and Team Center for Manufacturing. We have helped hundreds of customers produce maximum efficiency and throughput by ensuring full utilization and automation of Siemens PLM products. Of course, these are all based upon best practices within the industry. We also have partnered with Renishaw. If you didn't already know, Renishaw has a standalone product called Productivity Plus. Productivity Plus is a probing solution that enables full control of probing routines at the machine tool. We have flawlessly integrated Productivity Plus into NX, which now we call NX RSP Plus. It's very easy to use and extremely powerful and allows the user to create their own probing routines at the machine tool. In addition to on-machine probing, we're also working with Renishaw to develop further metrology solutions for the inside of NX Cam to help automate the quality process. If you didn't already know, Janus Engineering is the originator of Post Configurator, which of course is now inside of NX Cam. So we're class-leading developers as far as posts and machine kits are concerned. If you're looking for more solutions to manage tools, we have that as well in our unique package called TMGR, or Technology Manager. And of course, we have the ability to automate your NC programming through SpeedMill, automate your documentation through shop docs, and much, much more. So please contact your local Janus Engineering representative for more information. And now to dive in the topic of the webinar, NX-CAM probing, or Productivity Plus for NX-CAM. We've all been searching for easy to use and efficient probing solutions. Well, I'm happy to say we finally are bringing it to you. Productivity Plus is an easy to use, flawlessly integrated solution right into NX-CAM. And of course, the best part about it, it's 15 years old and was developed by Renishaw. We have just taken that product and flawlessly integrated into the NX UI. It's very easy to use. There's no programming knowledge needed for probing. And of course, right inside with NX, so we have traceability with inside of our manufacturing platform. All right, so before we jump into this video webinar where we're actually going to get to see Productivity Plus working at the machine and the same results being produced in NX, I want you guys to start thinking about how probing is going to benefit your manufacturing process. Of course, we've kind of already thought about this, so check out the bullet points here and let's start to talk about them. First, we're going to be able to reduce scrap. What does this mean? Well, we're going to be able to check the part throughout the process and check the in-process workpiece for critical dimensions. This is going to allow us to rework the part while it's on the machine tool, and of course, prevent rework in the future. We're able to control those processes through measured results as well. So if you want to adjust cut com, we're able to do that. If you want to adjust tool length, we can do that. If you want to change a coordinate system, we can do that. All of this is designed to simplify your manufacturing process. And for those of you who have robots loading the machine, guess what? Lights out automation is in your future with NX Productivity Plus. So with all of this, we're able to reduce production times with higher quality parts, more spindle time, less machine downtime, and of course, more money for our manufacturer. In addition to improving quality, we're able to avoid collisions, which I'm going to show you guys. So in case you had to move a clamp mid-production, we're able to check if that clamp's still there. And if our operator did not move that clamp, we're able to go to an M0 and so forth, avoiding a collision at the machine, which of course can be very costly. Once again, we're just continually improving quality during our production, showing you the benefits of NX RSP Plus. All right, here's where I get really excited about Productivity Plus for NX. So in the beginning of this webinar, we talked about a day in the life in the programmer and how we're going to drastically improve the process of manufacturing parts. So here's the plan today. We're going to start with part setup. Here we're going to come in there and use the touch probe feature to check to make sure the part is in the correct position. Now we can use touch probe to check clamping situations or scenarios. We can use touch probe to pretty much do anything at the machine that enables a trigger action. And then we decide what we're going to do with that trigger action going forward. From there, we're going to check the fixture and then make a correction based upon it. In this scenario, we're actually just going to probe the G17 plane of the stock and actually make a kinematic correction in the B axis to align selected plane with the G17 plane. And of course, because now we've made this kinematic correction, we've actually moved the original coordinate system of the part. So what we're going to do is come back in, probe that stock, and do another coordinate system placement of the part. And then from there, we're going to go into in-process checking. I can't tell you how important it is to check our part as an in-process workpiece. In a semi-rough condition, we're going to create a report with else and if statements. If the report meets our values needed, we're going to continue on with our manufacturing process. If not, we can stop the process or do something else with it, such as replace a coordinate system on the part. From there, we're going to do another x-axis alignment and align the new plane with the G19 plane. And from there, we're going to do a true position check and an MCS update and move the coordinate system to a feature on the part. Finally, we're going to do an inspection and kinematic correction angle adjustment. So first, we're going to start with kinematic correction for one of the angled pockets on this part. So what that means, we're going to go in there, we're going to check the part, make sure the part is at the correct angle needed for that pocket, and then we're going to do a finish operation on that pocket. And finally, we're going to complete an inspection report of the entire part. Now we can later use this report to send a quality
as a starting point for them for inspection, or if we qualify the machine ahead of time, we can actually use this report as a final report for our part, therefore eliminating the need for quality. So let's jump into NX and show you how to get this going. All right, let's talk about what we're going to do with inside of NX here. First, we're going to be using touch probe to check to see if the part or the fixture is aligned correctly. Then we're going to kinematically align the new fixture, or the stock in this case, with the Y and Z plane. And then finally, we're going to drop a new coordinate system based upon this new alignment that we did at the machine tool. So let's dive into NX and see how this is done. All right, you can see now that we're in our NX CAM environment. You can see we're sitting on a VC500. Thanks to our pals at Renishaw USA, we're allowed to use this machine for this demonstration. Of course, at the end of each of one of these NX segments, we're going to show you live at the machine and what we're actually doing. Let's take a look at the stock here first and the part. You can see we had a pretty basic part here with a few features on it and a pretty basic standard stock here. Now with this device, you can see that we could actually align the stock in two different orientations, and we're going to show you how we're going to check for that orientation here momentarily. So to start here, let's take a look at the integration of NX Productivity Plus inside of NX CAM. Productivity Plus works just like a operation template. You can see we can go to create operation, open up our Productivity Plus operation. We can select our program, select the tool, our geometry, and of course our method. If you want, we can put a name to this. So let's open up the dialog box and explore a little bit about Productivity Plus. So here you can see our general dialog box. So Productivity Plus works upon basic statements. So we're going to probe features, and from those features, we're going to collect data points. These data points are then stored at the controller level for future reuse and calculation using Productivity Plus macros. So it's very easy to use here. You can come in here, and for this instance, we're going to say that the stock, we're going to check to make sure the stock is not at 90 degrees, or let's call it parallel with the x-axis, or long ways with the x-axis here. So how do we check to make sure that we have correct alignment with the stock? We can come in here and we'll simply probe a point. So let's come in here, choose this point. We're going to choose the direction at which we probe. We can change our standoff distance if we wanted to. Let's call this 10. And if we wanted to, we can add some additional stock to that putter if we needed to. From there, what do we want to do with that point? We're going to use our touch test feature. So with touch test, all we have to do is select the point and then probe that point and decide what we're going to do with the trigger action or no trigger action. So let's come in here and select that point again. Now, the great thing about Productivity Plus is the ability to use the tools that we're so familiar with inside of NX. So for here, we'll say here, and we'll come in here, select the vector, we'll do a little offset on this, add at 25. Really easy to use here. All right, now let's put some over travel distance in, just in case the part isn't there. All right, this next feature is really neat. So this enables us to, using touch test, to enable us to check for clamps, check for fixture components. Maybe we have a feature on a pallet that we'd like to check to make sure we're loading the right pallet. We can use touch tests for many different operations and instances within inside of NX CAM. So first we're going to say, what happens if we actually touch the part? Well, in this case, we don't want anything to happen. We want to continue on with the next operation. What's really important is what if we don't touch a part, so no trigger action. So in that case, we're going to output an NC code. Simply, let's put an M0 in here, or maybe an M30 for a reset. And then let's put a comment in here. And we'll call this something like wrong stock orientation. Perfect. So now what's going to happen is that when the touch probe comes down and doesn't see stock, it's going to output this M30, reset the code, and also put a message on the screen that says wrong stock orientation, notifying the operator that he has loaded the stock incorrectly. All right, that was easy enough. Let's take a look at what that's going to look like at the machine tool. And we'll come in here using G-code simulation. And you can see we probed the part. All right, let's jump into the next operation. We'll take this item. You can see I've already created a few of these probing routines. I don't want to spend too much time as we're limited time with this webinar and we have much to cover, but we're going to take a look at how we've created other operations with inside of Productivity Plus. Some of the other problems that we run into at the operator level is making sure that parts are correctly aligned, correctly put in the fixture, or just correctly put into a vise. So in the instance you're going to see in the live video, we've actually put this stock into the vise fairly crooked and misaligned with the vise. So this would be the case if a parallel dropped down or if the operator wasn't paying attention. How do we make those adjustments automatically without scrapping the part or crashing the machine? It's very easy. We can actually come in here, probe a surface, and align that surface with a plane. So we're going to show you how we did that here. What we did in this next operation, as you can see, we've probed the top of the stock in 3 places. This defines the plane for us and allows us to make a kinematic correction at the machine using the B-axis. So let's take a look at what we did in this operation. All right, real quick here again. We only have a couple cycles that we called here. Very easy to do this kind of type of operation with inside of Productivity Plus. So what we've done here, measured plane feature, and we've selected 3 points with inside of here. Now, once again, we could have defined those 3 points by putting a point on that part, or we could simply use the tools with inside of NX and define a point on a plane. So here, and we could say something like this. All right. And of course, it shows us the probing direction and some additional outputs that we need. All right, so now that we've chosen that plane, you can see how easy it was to do this. Now, what do we want to do with this data that we just collected? In this case, we want to do a rotational update to make sure that now this plane is aligned with the G17 plane. How do we do that? Simple enough, we come down here to add NC update, and we'll select the one I've already created, and we're going to do an update type. Now in update type, you can see we have many different operations, or possibilities, I should say. Here we're going to use the rotational update feature. We're going to use rotational update, and then we're going to come back and choose that plane that we've already created. And then from there, we're going to say, we're going to update now around the y-axis. Because we are kinematically limited, we can only update around the y-axis with this machine tool. If we have a head-to-head machine, we have some more possibilities as far as how we want to align, or maybe we could line around the x, or both in that situation. So what we've done now is quickly created a kinematic adjustment or rotational update at the machine tool. So in the video, you're going to see the machine tool actually kick a couple degrees one way and align that plane with the G17 plane. Let's take a look at another way we can do an alignment. This time, let's align around X. So we can come down here and sweep the side of this surface of the stock and quickly make an adjustment kinematically to the machine, or a rotational update. So we're going to select this side of the stock. We're going to probe in a few points on the side of the stock, and then we're going to align that with the y-axis. All right, you can see now we're within inside of our operation dialog box. What we've quickly done is selected a line feature. You can see it right here, add measured line. We will come in here and we're going to select a couple points
with inside of our measured line here. And of course, we could say something like use point on face. And we'll use that again. And you can see we're quickly putting toolpath on the part here. Now, which direction are we going to probe? We are going to probe in the positive X direction. Actually, I put some additional stock on here, so we're going to offset that toolpath a little bit, and we can control our inspection depth from those points we collected. Now, if we came back here, we could actually say, instead of using point on face, maybe we wanted to use a inferred point. We'll choose the corner of this part for this one, and we can come down here and easily choose the corner of the part for this one. All right, great. Now, what's the problem with this? Well, of course, we don't want to probe exactly on the edge of the part. So we have the ability to throw some adjustment in there too. So we can offset that from that corner. We'll offset this from this corner. And you can see our toolpath moves for us. And maybe we want to control the inspection depth here, and we'll make it maybe 25 millimeters down. Perfect. If we want, we could also add some additional points to probe. All right, now that we've collected this data within the machine tool, we want to tell NX Productivity Plus what we want to do with that data. Just like we did with the B-axis rotation update, we want to update this around the Z-axis, doing a C-axis update for the specific rotation. So of course we come in here, we choose the operation type, and then we come in here, we choose the line. And of course we're going to update around Z. So what we're going to see in the video now is the machine make a slight adjustment to the Z-axis, and we're going to see that at the controller level with inside the offset. Finally, now that we have made all these adjustments, we want to come back and put a coordinate system back on our part. So just like we did in the beginning, where maybe we probed all four sides here and put a coordinate system in the middle, we're going to do that again, because now we're in the position where maybe our part has moved slightly, and we want to make sure that we're in the correct position. So let's jump in and check out how we put a new coordinate system on the part. As you can see here, this is a little bit more complex, but simple when I go through it here. So what we've done here is we actually probed in 1 point in the X negative, 1 point in the X positive, 1 point in the Y positive, and 1 point in the Y negative. And of course, 1 point in the Z plane. Now what we've done with those points now is we've created some construction lines. Here you can see that we created some construction lines between those points. This enables us to put a coordinate system in the middle of those points by using line between 2 points. Very simple, easily went in, selected the 2 points we wanted to use, and created a line between those 2 points, and continue on. We've done the same thing in the X position as well. Now, using MCS update, we can easily grab these features and put a new coordinate system in the middle of both of those lines. So let's take a look at the Y functionality, Y feature here. We came in here, update type, WCS update. We're going to choose a coordinate system that we want to update. Of course, this is the fixture offset 1 in our geometry dialog. We're going to update this coordinate system. Of course, we also have the additional ability to set it manually, where we could set manually and also add some additional offsets in there if we wanted to. So, but we're going to just automatically update this. We're going to update in the X and the Y. And of course, all we got to do is push OK. We'll do the same thing in the X axis now too. So you can see very similar, do the same thing in the X axis. And of course, Z. And we've automatically put a new coordinate system on this part. So you can see NX Productivity Plus is very easy to use. And of course, from there, we can come in and use our machine tool simulation and simulate this whole operation. Okay, starting our cutting now.
All right, guys, that was the first segment of Productivity Plus. Now we're going to jump over to Stephen at Renishaw USA and let Stephen tell us how this is going to happen at the machine tool.
Hello, my name is Steve Kerr and I'm an application engineer at Renishaw. Today we're going to talk to you about probing and on-machine probing using a CAD system inside NX and a Productivity Plus program to use it to find the part on the machine tool and then do some on-machine inspection. In this example we have a part that's been misloaded and we're going to use the probe to find the part and see whether the part is in the machine, and also if it isn't in the machine it's going to stop the machine with an alarm. If the part is in the machine, the probe is going to continue and then carry on finding the part and aligning it to the correct position for the machining. Even though the part is misaligned, the probe is going to find it and align the axis to make the part level and square in the machine tool. So we're taking a plane on the top and it finds the error and then aligns the B-axis to the correct alignment. We also do the same on the C-axis to find any rotation errors there. Now that once we've aligned the part in the machine, we're going to set up the work offset to the center of the block.
All right, thanks Stephen for that awesome on-machine presentation of Productivity Plus and how we can increase our throughput throughout our part setup. Of course, some of the advantages we just saw was verification of the correct part setup with the appropriate MCS on the part, allowing us to make sure that the correct part is loaded correctly at the machine tool. This, of course, is lowering our risk of a crash or tool breakage at the machine. And of course, finally, because of that, we're reducing scrap. We're also able to verify the kinematics of the part and compensate automatically using rotational updates. All of this is going to enable our shop to have lights out production and, of course, decrease our machine downtime and increasing our productivity on the shop floor. Let's take a look at our next process. And now for what I think is one of the most important parts of our manufacturing process, in-process probing. Here we're going to check the part in the in-process state. In this condition, it's going to be a semi-rough condition. Here we're going to create measurement reports and have the ability to either reject the part at this condition, make changes to the program automatically, or continue on with our manufacturing process. As we continue on after the in-process report, we're going to come back in and do another x-axis alignment, aligning a datum with the x-axis. We'll call this a rotational update. And then we're going to come in and do a true position check on a few more holes, and we're also going to update an MCS or move the MCS on the part. Okay, so we started at the beginning of this webinar talking about the part setup and how important it is to use probing to set up our parts. But what about the in-process workpiece or in-process part? How can we use probing to make better parts, decrease our scrap, and of course, check for quality issues throughout our manufacturing process? So I'm going to show you a few things here in which we can do. Of course, we can do things like update CutCom along the way, not just create reports, but really use it to automate a lot of our manufacturing processes. So here you can see we've created some probing routines. In these routines, we're doing simple checks here. So in this instance here, we've actually probed each one of these datums in the X positive and the X negative plane. We're going to use the center point of that datum to take a measurement from. We've also put a point in the Y negative and the Y positive. We're also going to create a construction line between those points. And then we're going to also check these bosses as well as bores for dimensions. So let's take a look quickly here how we define the line between these 2 points. We've used the midpoint of the datum there and the midpoint of the other datum to create a construction line. We can then use that construction line as a measurement feature. We've also done the same thing in the y-axis, where we actually create a construction line in the y as well. And then we've created an additional construction line between 2 of the features here that we can use for true position. So What else can we do besides just creating these measurement lines? Well, we can create reports from them. But what if we wanted to find out or automate that process, whether the part was good to start or bad to start? Well, we could, for example, check the diameter of this bore and say if the bore is not within less than or equal to 0.02 millimeters, we can then reject the part or continue forward. In this case, we reject the part with an M0 and put a statement out for the operator. So what about in-process reporting? We can also do that too, to find out maybe where the manufacturing flaw happened in the part or we had problems along the way. So we can see we've created an in-process report using the following features. And it was as simply as creating an in-process report, selecting those features, clicking the tolerance button so we can reference the tolerances in the report, and continue on. Of course, this report automatically generates at the machine control, and if you're networked properly, you can access it from any one of your computers or local workstations. Okay, so now that we've created an in-process report, checked some of these features, what else are we going to do here? Well, you saw us align in the y-axis before with the stock. What about realigning in the x-axis and just checking that out? So you can see here we have probed this datum in the y negative, and then we've done an NCS update. So we've done a rotational update here based upon that feature around z. So now this datum is parallel with the x-axis. So if you remember earlier, I said we're always collecting data points. Well, how can we reuse those data points without having to go in and reprobe that feature? So I reused a data point that we already probed just recently in the in-process reporting, and I reused that to create an MCS update. So you can see here, I went in, found that circle from the in-process reporting, which is actually this bore you can see is highlighted. We've used that feature now to update our coordinate system and actually make a coordinate system adjustment. So we're not going to stay in the 54, we're actually going to go to the 55 now to finish it. So you can say that maybe the inside of this bore, the true position is critical to maybe this pattern here and some other features on the part, and this datum is based upon the center of this bore. So we've updated that in the X and the Y. We put a new coordinate system on the part. And of course, we've come in and also probed in Z. So now we have a new G55 based upon the center of that bore and the current stock position for Z. So this is some of the features we can use with inside of Productivity Plus to increase our productivity and quality on the shop floor. Let's jump to the machine tool and see how it works with Stephen.
Okay, so the next part of the story is the in-process inspection. So this is a critical phase that sometimes people can tend to forget or overlook. It's very important to make sure that the parts are correct prior to them being finished machined. Because if you're making very expensive parts and you're halfway through the process and the machine makes the part scrap or incorrect, you can then waste a lot of time and a lot of money remachining the part again. So what we do is we can check something part way through and use some logic to make sure that the part is good. If it's good, we carry on. If it's not, we can stop with an alarm, or we can go back and recut it.
Okay, before we jump into our final inspection process using Renishaw Productivity Plus, let's talk about what we just did. So we used in-process probing here to check parts for tolerances during production. So midway through our production, we're actually checking for critical tolerances, whether these are true positions or just basic tolerances so we know that we're within spec. This process is not only going to help increase quality, but it's going to reduce the amount of rework that we have going forward in the future. With that said, we're also automatically able to update Capcom and tool lengths for lights out production so that you guys are running robots at your facility. We can help you automate this process throughout the night. Of course, more spindle time every day guaranteed using this type of process. And with more spindle time, our end result is increased throughput at our machine tools. All right, so now for the final inspection process. This is going to be really simple and straightforward, but to give you an idea, we're going to do the same thing we did in the in-process workpiece. We actually just copied that operation right over and did a final measure report that we can later use down the line. We've also created some additional if-else statements in there that I've changed for true position of the bore, and as well as we measured some additional specific features as the hole pattern around the bore. So let's take a look how we did that with inside of NX. Getting down to the final bits of this webinar, we're going to talk about the final inspection. And of course, the final inspection is going to enable us to prevent scrap or maybe check a part before we take it off the machine for possibility of rework. And of course, if we qualify the machine ahead of time, our machine tool becomes a CMM, therefore not needing the need to go to quality for final inspection. So let's take a look at how we created this inspection process. Here you can see we actually just like within NX, we copy and pasted the operation, and with some additional feature changes, we're able to inspect using a lot of those same features within inside of the in-process inspection. You can see here we added some additional features for the final inspection, including a best fit scenario for this hole pattern around this hub. So here you can see that we've measured 4 points on here, and then using a best fit scenario with least squares, we've created an additional measurement for best fit. In addition, we wanted to also check for tolerance on this boss. So maybe we're critical dimensions in the X value. So right now I've created a else statement here, or an if statement that says if the X value is greater than 0.01, then to reject the part. If not, we continue on and produce a final inspection report. And just like we did in the in-process workpiece, we can create this inspection report the same way. We add the features we'd like to create. In this case, we've also added all those additional fit features for the hole pattern. And we added the tolerance value in as well and create the final inspection report. And for those of you looking for what a final inspection report looks like at the machine, this is an example of a Siemens report. You can see we have all the raw points and the data collected, and we can use that later for our inspection purposes. Of course, all of this leads up to our ability to increase our throughput at the machine, make better parts, and of course, reduce our scrap when making parts in our manufacturing facility. Now let's jump to the machine tool and see what Stephen has for the final inspection.
This is the final inspection of the part. What we do on here is we can check critical features to ensure that they conform to the print. If any of the parts or the features aren't correct, we can adjust them on the machine automatically by updating a work offset, a tool offset, or any rotation updates. We can also add logic into the program. What that means is that if the part is too big or too small, we can make the controller automatically make an adjustment if it's incorrect. And if we need to, we can tell the controller to go back to a certain feature to remachine it. So then we can do an update again and get the part correct so we do not get any scrap or any rejects.
All right, thanks again, Stephen, for showing us that final inspection at the machine tool and the value we can bring to the table using Productivity Plus for NX. Of course, some of the advantages are increasing throughput, limiting our machine downtime, increasing first article part production time, and of course, turning our machine tool into a CMM for final inspection reports. And those of you who have robots already loading machine, this means lights out production and better quality parts. So let's jump into a quick final review of Productivity Plus for NX. So of course, we can reduce costs through scrap prevention by checking our in-process workpiece and setups. We're able to check critical dimensions on the machine to prevent rework, and of course, control those processes by adjusting cut com or tool lengths automatically throughout our manufacturing process. All this is going to simplify our process for lights out automation and reduce production time with higher quality parts. One of the most important things I think we can take into account is our ability to avoid collisions. So if we do have an instance where we're moving clamps, we can check if those clamps are still there, or we can check that if the clamp is put in place so we can continue on with our machining, preventing collisions that can cost us money in the long run. All this will continue to improve our quality during production, create less machine downtime, more spindle time, faster article parts, and finally, we can turn our machine into a CMM. I want to thank everybody for joining our webinar today. And just a quick review of who we are, Janus Engineering Americas. We're a full-service Siemens PLM support provider for NX CAD and CAM. We also have our own line of products, including Technology Manager for tool management, of course, Productivity Plus for NX, some automation programming products such as SpeedMill and SpeedWire, and much, much more. So please contact your local Janus representative for more information. So without any more, let's continue on and let's get into the Q&A of this webinar. I want to thank you again and have a great day. All right, everyone. Thanks for sticking around. We're going to start with some of the questions that were asked in the dialogue. I believe Andre is going to read those off for us.
Yeah, thanks for that, Tim. Okay, so let's have a quick look here if there's any raised hands. Second, no, it looks good. Okay, so we've got a question here. I'm going to read that out. So are the points and lines being constructed in the software dialog associative to the part model? Meaning if the model updates, do the points and lines also update and move if the surface changes?
Yeah, absolutely. Just like any other NX operation, it's all associative to the part. So if that part grows, our points are going to move with that part. Of course, we have to pick a point on that surface for it to be associative, but it is 100% associative with the part.
Okay, fantastic. Thanks for that, Tim. Let me read you another one here.
Did we have Stephen unmuted as well, please?
Yeah.
So he can join in. Yeah.
He is. Yep, Steve, if you can hear us or if you're able to jump in, let us know. Okay, Steve.
Hello, everyone. Can you hear me?
Yes.
Gotcha, buddy.
Hey, good. How's things?
Good,
we're doing great. We're doing great.
Good. I see some good questions there.
Yeah, fantastic. Okay, let me go ahead and read the next one here. So how are we handling the Renishaw code in the post? Do we have a specific post for the probing?
So yeah, so the Renishaw post for Productivity Plus is integrated into either a post that we have developed for you guys, or we can actually integrate it into a post that we haven't developed for you guys. It basically works off a statement where we, when Renishaw Productivity Plus is used, we call the Productivity Plus post. Now the Productivity Plus post is very conversational, is set up at the machine tool. So during the install, I would say at Productivity Plus, we usually have Stephen or Gianni from Renishaw come on site, configure the machine and the post processor for use, and then we obviously integrate, the Janus team here integrates that post into your either current posting solution or one of the posts that we've created for you. So like I said, it is full traceability throughout the program. So you post like you would normally, and with inside of that program, you get your cutting as well as your probing solution included. The post is pretty, it's universal. I shouldn't say for machine tool. Everyone has their custom post for the machine tool, but it's all based upon an easy to edit file, I would say.
Excellent. Thanks for that, Tim. Now, this next question, I don't know if we can necessarily get into it right here on the webinar. If not, we will gladly reach out to you and answer that question separately via email, phone call, or just a personal webinar later on. So the question is, please show the NC code file that is running on the machine. So
yeah,
Tim,
I am. I'm currently looking for some of the posted code that I have.
Okay,
so,
fantastic. So we'll come back to that.
We can come back to that question.
So the next question is, how do you handle custom Renishaw macro execution with the software?
Yeah, I'm not sure I understand that question. Steve, can you jump in on that? You there, Steve?
That's okay. In any case, obviously we know who asked that question, and we will get back to you and answer the question. Not a problem. Let's go to the next one. What Renishaw macros are needed on the machine? Does it use inspection plus macros,
Hold
or
on,
are
Steve.
there?
Hold on. Go back. Steve's muted here, I think. Yeah, he's muted.
Yeah.
There you go. We got you now, Steve.
Okay. Yeah. Can you hear me?
You're in the
Yeah,
background.
you sound a little far away. You try again.
Right now.
There you
Okay,
go.
perfect. So Steve, I'm just going to reread the question.
Yep.
How do you handle custom Renishaw macro execution within the software?
Well, I mean, the macro, we don't actually have anything like custom macro execution as such. I mean, the macros are posted from our post processor, and that's really the only way that any of the macros are handled. There are macros that are created when we post the program. Not sure if that was, unless they can elaborate a bit more on the question.
Right. So we'll give that person a chance to come back. If they come back on the chat and ask, give more details.
Oh,
we'll gladly.
that's Rich too. Rich, I can give you a call and we can talk about that, Rich. No problem.
Looks like he reiterated it there at the bottom there, Andre.
I don't have any other questions from Rich except the one from 15 minutes ago.
He said the custom Renishaw macro execution question relates to those inspection methods macros we made at PCC based on standard Renishaw macros.
Yeah, well, the macros, they're not what we would call standard macros. They're not inspection plus macros. They are specifically for tests.
Oh yeah. So I think Rich is using inspection plus at the machine tool. So the inspection plus macros don't cross over to be productivity plus macros. So there's not an alignment between inspection plus and productivity plus macros. I did just put an example of what it looks like to post here with Renishaw Productivity Plus. So this is kind of what we get in our program. It's not kind of, it's what we get in our program. And you can see here we have some setup macros, and then we jump into our machining here at the bottom. And then for Ron, so the we just couldn't answer the inspection plus deal. So what happens when we create the post? We basically recreate all the macros needed with the post, and we load those macros on your machine tool, and you should be good to go. So it's not like you have to load. We load all the macros for you for a Productivity Plus. And then as far as it's not really. I wouldn't say that they're Siemens and maybe Steve can speak to this. I'm not sure if you can see that, Stephen, but I'm not sure. I wouldn't say they're necessarily Siemens or Fanuc or OSP based. They're kind of based upon the developed post for it, for that actual machine tool. As we generate the post, we're able to we regenerate the macros and then install them on the machine tool. Is that right, Stephen?
Yeah, correct. Yeah, they're specifically
Yeah.
for whatever controller, whatever post processor we have for that machine or that controller.
And then at P, I think globally right now, I think we're like 125 users right now, globally. Lance, does this machine tool need software updates past having the Renishaw software loaded currently? No, I don't. We don't have to do any updates. We're literally just calling macros within a stored file location at the controller. So with our updated macros, obviously, you can see the code here. We're calling the macros and then calling the positions and then using the macros accordingly. How many macros are consumed in the controller for the software? Hey, Steve, what is it like it's like a dozen or maybe 20?
Yeah, there's a minimum of I think around about 30 something.
30.
Variables. Yeah, and
Yeah.
then you could. It depends. The more complex program that you're running, you're going to do a lot of reporting and a lot of updating, and it needs more variables to store those variables. So yeah, it just depends on how complex you make the program.
Yeah, I think the last controller I set up, we had like 100 variables set up in a Siemens
Yeah, that
840.
was the minimum. Well, not the minimum, but the minimum is round about 30.
But now, of course, the more we probe or the more locations we probe, the more spaces we need to put that variable, right? So,
Right.
if we're probing 300 points in the part, we're going to need 300 variables to consume those points. Do we want to get some live questions going here? Does anybody want us to unmute?
I don't see any hands raised right now, but if you'd like to do that, go ahead, and we'll gladly answer your question in real time. I've got another question from Lance. When you post the recording on YouTube, will it have this Q&A session? This has been an informative session. I'm not sure at this point. We'll definitely have the video that you saw, that for sure. And then as far as the Q&A session, I'll probably I'll make it available to you guys. I'm not sure yet if I'll put it on the YouTube channel. But either way, yes, everything is being recorded, and we'll make it available.
And we definitely want to get you guys involved on a personal basis too. I know there's a lot more things we can do with Productivity Plus, and there's going to be questions along. And it's so powerful and robust that this we kind of showed off a lot of the basics and how to start automating some of your manufacturing process. But obviously, it's quite a bit more powerful than what we're able to show on this 38-minute webinar.
Exactly.
So what we really want you to do is call us, set up a meeting, and let's jump into this on a more personal level. And we could even use your part, on a machine and kind of show you how we would get this done. Or maybe some of you out there are using reworking, previously made parts that have been, warped in the past, and now we're refixturing them, or maybe we're working from castings or forgings that are not straight, and you want to see how you can align them at your machine to have a better starting position. So we can show you how to do all of that on a one-on-one session. And I think the best part is using your part to show that off, your part, your fixture, your setup. And if you're lucky, maybe we'll even have your machine tool that we can show you in simulation as well. From the simulation side, I will say that we can simulate the variables for Productivity Plus. Now, of course, there's not really a lot of value in that because in NX we're in a perfect environment. We're not typically setting our part up crooked in NX and then having the machine make the corrections. So we typically just do like a quick G-code simulation showing that the probe is going to go to the correct positions and then go from there. Do we have any more questions? Like I said, we can even, if you have something that you don't want to type out and you want to talk about it, we can unmute you and have that conversation.
Hang on, we've got a hand up. Go ahead, Ron.
Hi, can you hear me? This is Ron Tellerico from Pratt.
Yeah, we hear you. Go ahead.
Got you, Ron.
Ron?
Anyway, I just am curious about future upgrades, NX release activities that we do as within our companies, how this product is updated. So do you provide, I'm sure as part of, there's probably some maintenance with all this. Do we get updated operation templates that match kind of like the, any enhancements that Siemens makes, or just the look and feel of those dialogues? Does that happen every year? Is that something we would also get as a part of a maintenance renewal, or what do you plan to do for that?
Yeah, so I mean, like right now, it's the update is basically based upon an NX open file. So when you go to a new version, we have to update some of the files, just so the two-way communication between Productivity Plus and NX works. But yeah, obviously, yeah, just like any other maintenance program, we definitely give you guys the update, and we try to ask our customers to let us know when you're going to update, so all of a sudden you're not stuck in a position where you're like nothing works. So we can kind of get a test environment going first, and updating templates that need to be updated. I will say we continually update Productivity Plus with for NX with the Productivity Plus updates with Renishaw. There is some talk about some future updates going forward, and we're actually working on a new, even easier to use dialogue box with inside of NX. It's going to allow us to reuse previously created templates and stuff like that. So it's continued development, and obviously as we gain more users and more pace with Productivity Plus with our NX, we're going to continue to develop it more, and go from there. So.
Okay.
Fantastic.
That's good. I do have a second question too, actually, if I could. I know we're getting past some time, but so we have a combination of Verica simulations and ISMV simulations within Pratt. Still pretty heavily used in Verica. Are the Productivity Plus, whatever you want to call them, the software on the machine tool, available to be configured and used in Verica, or are they encrypted files? Or
yeah, no. Actually, we
like
have some customers. Yeah. Oh, sorry, Ron. Yeah, I don't mean to interrupt you.
I'm just saying I've taken Inspection Plus macros, from the control, read them as text files within Verica, and I can simulate a lot of stuff, outputting variables, things like that, outputting pound 135 or what have you within Verica pretty easily. So is the Productivity Plus text files, so to speak, able to be read by human readable format?
I mean, you could see what we're outputting from the Productivity Plus post right here, Ron.
Yeah.
Yeah.
But there's
Essentially,
it would have to be.
you can run those macros through Verica exactly the same as you would do on the machine tool. Do exactly the same. As long as they set up Verica correctly, it'll do exactly the same thing.
Okay. Yeah, I mean, obviously, Verica needs to be configured, to read some of that code, but we do that for Inspection Plus.
Yeah.
So I just want to make sure Productivity Plus code that's loaded on the control can be extracted into a text file and then subsequently be configured to read in Verica. That's all. Sounds like it can.
Yeah. It's just like I said, it's just aligned with your post processor. So whatever posting code you're going to come out, you can run through Vericut, and as long as those variables are in your Vericut solution is configured correctly, it'll work no problem. We can also do that with inside of NX simulation, although it's typically we don't go that deep because you're typically set up in a perfect environment. We just set our post up to output for the simulation only, output simple ISO G code format for the probing, so you can actually see the probe going, touching the corners, touching the part at whatever points it needs to, and then continuing on. But for the customers that do request the ability to have that, be able to read the Productivity Plus code, we can 100% do that for you with inside of simulation. It's a possibility.
Perfect.
Okay,
Thanks for that, Tim. In line with posts, I actually have another question here regarding that from Todd. He's asking, can this be used with a third-party post processor, or do we need to have an NX post?
For this, we need to have an NX post.
Correct. That makes sense. That's the integration. That's the power of the solution. Correct. Okay. I've got another question here. What would be a typical product development time frame, for bug fixes and enhancements?
Yeah, I mean, right now, we're using a lot of the already currently developed power of Productivity Plus from Renishaw. So we're kind of on a Renishaw timeline. So, right now there's just to let everybody know, right now we really only work with machine tools that have a kinematic for milling. So if you are like a straight turning center, Productivity Plus does not work. Although there is a large inquiry, especially from Ron and Renishaw, our pals over in Renishaw in Great Britain and also in Germany, that now we have a bit of a focus now to develop some enhancements to work in the turning center. So, Productivity Plus has been around, I think Stephen can confirm, I think it's 15 years now.
Yes, yeah, 15, 16 years.
Yeah, 15, 16 years. So we're really just pulling from their software to drive all of these probing solutions. So from the probing side and software development really comes from Renishaw. Now, I think we're running off version 2.9 right now, and I think the next version we have coming out this fall will be 3.2, which is the most recent. I think it's 3.2 right now, right? It's the most recent.
We're currently on 3.4.
3.4.
Yeah.
So we're working on being in the fall up to the most recent version of Productivity Plus with enhancements. So we're definitely with the integration of NX, we're a little bit behind the release of the Renishaw product, but we're not far. I think
Yeah.
Jan Lindenberg out of Germany is one of the lead guys for this product, and we work closely with him on updates and enhancements.
Yeah, so as far as the version goes, though, Tim, it's not a major issue for the macro mode. So most of any advancements we do Plus is more geared for the scanning probe. So for the touch trigger stuff, 3.2 is still very current.
Yeah. Yeah, and that's one thing that we do want to add to this enhancements is the ability to do scanning, which isn't a possibility right now. But I would say within the next year or so, we're going to have the ability to do scanning with inside of Productivity Plus, for NX, I should say.
Excellent. Thanks, Tim. I've got another question here. I'm not sure if we touched on this with a previous question, but I'm going to go ahead. It's from Kenny C. How many macro variables are reserved for this within the controller?
Yeah, we did. It's depending on the controller, but we need around about a minimum of 30, 35, something like that for the local common variables.
Perfect. Thanks, Steve. Okay, let me see. I don't see any raised hands. If anybody has any questions, you can go ahead and put them into the Q&A or the chat, or simply lift your hand. If not, I did put in the chat our email address, or you can find us, of course, on LinkedIn. You can find us through our YouTube channel. You can give us a call at our 1-800 number. The whole point of this, like Tim was saying earlier, was to sort of give you an introduction into what we can do. But really the point is to have a discussion with you about how we can help you specifically using one of your machines as an example, and have a chat with you one-on-one. I've got a question. What is your YouTube channel? Yep, if you just scroll up, I put the link. I'm just going to put it once more. Give me a second. Let me grab it.
And we do have a webinar again next week. It's going to be the same webinar, but if you wanted to get more of your team involved and watch again, of course, the questions will be different because hopefully we'll have different people on it. And we won't be posting this to our YouTube channel until after that second webinar. We want to encourage people to get into the webinar and ask questions and really have a chance to dig deeper with this product.
Exactly. Okay, I'm just going to put the YouTube channel link on there once again. to answer your question, Struble. There you go. So that's the link to our channel. We'll be posting, like Tim said, this this video right after. And but yeah, hopefully you guys enjoyed this. And yeah, like Tim said, we have the same one again going on next week, same time, same day. So next Wednesday. And yeah, it was a pleasure. I hope you guys got something out of it, and we look forward to talking to you guys again in the future.
Yeah, thanks everyone for joining, and yeah, look forward to maybe even seeing you again next week.